In this lesson, we're going to discuss how to prove that triangles are similar. Now remember, similar means basically same shape but different sizes, okay? And the angles are congruent, but the sides are proportional, okay? For instance, if you had two triangles like that, where all the angles matched up, okay? All those angles are the same, they match each other, and then the sides are proportional, something like that. Now, the long way to do this is to check off that all the angles are congruent and all the sides are proportional. Today we're going to learn some shortcuts. First shortcut here is called angle-angle similarity. And what that states is, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So for instance, if I had angle B congruent to angle R, and let's say angle A was congruent to angle Q, okay, that would be two angles of one triangle equal to two angles of the other triangle. So in this case, triangle ABC would be similar to triangle QRS by angle-angle similarity. The next shortcut we have is called side-angle-side similarity, SAS similarity. And this states if two sides of a triangle are proportional to two sides of another triangle, and the included side, the included angle, the included angles are congruent, then triangles are similar. So let's say side AB was 2, and let's say side QR was 4, and let's say AC was 3 and QS was 6. So looking at those sides, 2 over 4 and 3 over 6, they both equal the same fraction, 1/2. So those are proportional. Now the included angle would be the angle in between the sides. That would have to be angle A and Q congruent. Okay, and that would give us side angle side similarity, side angle side. Okay. Last we have side 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 similarity, and that states if all three sides of a triangle are proportional to all three sides of another triangle, then the triangles are similar. Let's go back to our example here. If we had those sides are 2 and 4, and these are, let's say, 3 and 6, and these two are over here 4 and 8, okay? 2/4, 3/6, and 4/8 all break down to 1/2, so that would be an example of side 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 similarity. Or we don't even have to worry about the angles. Okay, let's try some examples. Well, before we do that, we have one more thing to talk about, and that's called indirect measurement. Indirect measurement is when you use similar triangles to estimate hard to measure distances. All right, examples would be like the height of a tree or a building, okay, or maybe a flagpole. Okay, we can set up similar triangles in real life to calculate and to estimate how tall those things are. Okay. All right, now let's try some examples. All right, the following examples is asking us, are the following triangles similar? If they are, all right, we're going to explain why, and we're going to write the similarity statement. Okay, so remember we have angle angle similarity, we have side angle side similarity, and we have side 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 similarity. Those are the three. Okay, those are the three ways. So let's try example one. All right, in example one, none of the sides are labeled with numbers or tick marks. So I'm going to go ahead and ignore any of these that deal with sides. I'm going to focus on angle angle. Now, one thing I notice is that these two angles right here are vertical angles. And I know vertical angles are congruent, okay? So there's one pair of angles. I also see that FG and JK are parallel. Now that creates some familiar angles. Hopefully you remember alternate interior angles. So if I trace that and I see the letter Z, I remember that these two angles right here are alternate interior angles. So we have a pair of angles from that triangle and a pair of angles from that triangle. So this one's yes, angle angle similarity. All right, and then we're going to write the similarity statement. So triangle FGH would be similar to triangle KJH. All right, example two. Let's try this one. All right, and these two triangles are on top of each other. All right, first thing I'm going to do is I'm going to take these apart. So I'm going to have the small triangle, which is NMP, and these sides are labeled 8 and 8. And then I have the bigger triangle, which is NQR. Now these two sides I'm going to have to add up 8 and 10, so that's 18, and then 8 and 10, that would be 18 as well. Okay? Now according to these two diagrams here, I have some sides labeled, right? So I have a pair of sides here and a pair of sides here. So I'm thinking probably not side, 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 because we don't know what the third sides are. So I'm going to ignore side, side, side. It could be angle, angle. We don't know. And I'm leaning towards side, angle, side. Now, first thing I'm going to do is check the sides and see if they're proportional. Okay, so this 8 matches that 18, so 8 over 18, and then we have 8 over 18. So those both reduce to 2/9. Okay, so the sides are proportional. Now you can see both of these triangles have angle N in common, right? So they share those two angles. It's the same angle in both. Angle N is congruent to angle N by the reflexive property. Okay, so that gives us side angle side there and side angle side here. So this one's yes, side angle side. And my triangle similarity statement would be triangle MNP is similar to triangle, that would be QNR, by side angle side similarity. All right. Next we have this example over here. Now all three sides are labeled, so I'm leaning towards side, side, side. But what I have to do is I have to check and see if these sides reduce down to the same fraction. So let's start with 40 from the small, and that would match 60 from the big. All right. Let's go to 30 and 45. Those match. So 30 and 45. And then we have 22 and 32. All right. All right, so 40 over 60 reduces to 2/3. 30 over 45 reduces to 2/3. All right, we're off to a good start. 22 over 32 reduces to 11/16. That does not work. So this one's a no. All right, it was almost side, 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 but it didn't quite work out. All right, now we're going to use some similar triangles. First, we're going to explain why the triangles are similar, and then we're going to find the value of x. So looking at example 4 here, okay, I have some sides labeled, and what I notice is these two sides that are labeled uh, have an angle also, and the angle is not in between them. So I know side angle side is probably not going to work. All right. The third sides are not labeled, so I'm not going to use side, side, side either. So we do have a pair of angles, and we also have vertical angles. That would be our second pair of angles. So this one's angle-angle similarity. Now I'm going to set up a proportion. Since these triangles are similar, I can set up proportions because the sides are proportional. So I'm going to use this triangle over here first. 24 I'll put on top, 22 I'll put on the bottom. And over here I'm going to match up these sides accordingly. So 24 matches 14, which would go on top, and x would go on the bottom. And then I'm going to go ahead and cross multiply. Okay, so we cross multiply there, we'll get x equals approximately 12.8. All right, that would be this approximate length, 12.8. Let's go ahead and look at example 5 here. All right, example 5, all right. First we're going to see why they're similar. One way, we have a pair of angles there, and we also have a pair of angles there. So it could be angle-angle similarity, or we also have these sides and those sides. So we have side angle side as well. Okay, so either one of those would work in this instance. Okay, now let's set up our proportion. Okay, so I'm going to use 5 and 3 from this side. So it'll be 5 and 3. And then we're going to match these up properly. 5 matches x, so x goes here, and then 4.5 goes there. So if I calculate this out here, all right, I get x equals 7.5. All right, and that's how we use similar triangles to find missing values. All right, the last example deals with indirect measurement. Okay, in this example, it says, in sunlight, a cactus casts a 9-foot shadow. At the same time, a person 6 feet tall casts a 4-foot shadow. Use similar triangles to find the height of the cactus. All right, so we have our sun here, and our sun is giving a cactus. Let's draw a pretty crappy cactus. And that cactus has a 9-foot shadow. Okay, at the same time, all right, a 6-foot tall person has a shadow of 4 feet. So if I kind of visualize this, I have two similar triangles here, and I'm trying to find the height of the cactus. So I'm going to set up proportions. So I'm going to set my proportion up. I'm going to use the cactus over here, be x on top, 9 on the bottom, and then match them up. That means 6 goes on top, 4 goes on the bottom. When we cross multiply here, the cactus would be, let's make sure I calculate this right, would be 13.5 feet. And that concludes the lesson on how to prove triangles similar. Hope you got something out of it, and have a good day.